What's up, everybody? Today we're talking about CMEs, coronal mass ejections. Basically, I want to dive into this interest is because we just got some images and also we got some video from the Parker Space Probe that's currently, you know, diving deeper into the sun and gathering a lot more information, basically showing the anatomy of the sun, just researching everything in its outer atmosphere, but also seeing how all that stuff, that plasma and all that heat is generated, from its anatomy. Basically, what we're also seeing from the video is showing the CMEs, the coronal mass ejections, solar plumes, just basically the magnetic field lines that's whipped out from the sun's core. So basically, what is a CME or coronal mass ejection? A significant expulsion of plasma and magnetic field from the sun's outer atmosphere, or we call the corona. Basically, the little corona is the outer atmosphere. Basically, when you see an eclipse, that's basically what you're seeing. It's the corona. So, Barker Solar Probe is spying on solar winds as it kind of does this little U-turn shape. And what's causing this? What is causing a CME? So CMEs is basically these little coronal holes, and these coronal holes are massive. They can, it's like a giant tear that's only like several thousands or hundreds of thousands of miles. And we can see these in many different areas of the sun. So basically, they're caused by twisting of the magnetic field lines that's explosively snap and realigning in a process called magnetic reconstruction. So basically, they're just tearing themselves apart. They're just twisting and they're just pulling way too tightly. And then, if they pull too tightly, they tend to tear apart just like a single piece of thread. Um, so that's what causes these field lines to basically just rip out and they just whip across, past Earth's orbit, basically. Um, some can snap back after burst and kind of just do that little U-turn, because they're snapping back and forth, and like I said, they're just twisting and pulling, and then just whatever, the slow particles and the slow magnetic field bands, they usually, like I said, they tend to kind of come back. So they just do this U-turn and then regenerate, and then, they can outflow. Basically, they just reconstruct, basically. And we can also see extreme causes where the CMEs are so violent. And this is usually due to the sun going through this tantrum, this 11-year uh, tantrum cycle. And this is what we're calling like the most violent stage. So basically, why are we so interested in seeing space weather is because, you know, activity like this, like these extreme coronal mass ejections, we've been seeing a lot of these coronal holes and the extreme violence of the magnetic field lines on the sun for, you know, for a long time. And like I said, this is a 11-year occurrence where the sun goes through this temper tantrum. Because we just had one just recently, and it's actually still going on. And also, that's kind of why you've been seeing these auroras even as far south as, let's say, Florida, Mexico, or other places that are just farther south. So that's weird because usually the northern lights are just north. They're far north, like northern latitudes, but they're just reaching so far south. It's a very weird occurrence. It's not becoming rare. It's becoming more common. It's because the sun is going through this 11-year cycle. These coronal mass ejections, these coronal holes that are always being ripped apart. And like I said, these solar, these sunspots are getting wider. But yeah, this is going through that 11-year cycle. And the reason why we want to understand about space weather and solar weather is because if anything like this happens and it interplays with Earth's magnetic field, and this is what's causing a lot of blackouts, basically. It's because of the sun's activity pushing out all these CMEs and how these little particles and photons of light, just interacts with Earth's magnetic field, and this is what's causing blackouts just anywhere around the world, basically. That's what happened in 2003, or what happened back in the 90s with the Quebec, or just recently what happened in Brazil, for example. Like I said, they can happen basically anywhere. Blackouts happen anywhere. It's because of the coronal mass ejections, and like I said, sun's activity is ramping up. At 11 years, or it could be a little bit sooner because of the sun's increasing activity. So yeah, so basically that's just the anatomy of the CME and basically the understanding of solar weather, basically. So thank you guys so much. Merry Christmas, ladies and gentlemen. I hope you guys have a splendid Christmas and Happy New Year. Bye. And as always, keep exploring.